This lesson is patterns and relationships found in right triangles. It says that we want to explore the relationships among whole number side lengths in right triangles, and we've talked about that before. Those are Pythagorean triples. I'm going to abbreviate Pythagorean triples. And then we also want to explore the patterns among the side lengths of right triangles within squares and equilateral triangles. There are going to be some special relationships that exist. So we start by, again, just defining the Pythagorean theorem. And any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. In other words, a squared plus b squared is equal to c squared when a and b are the legs of a triangle, a right triangle. So this could be a and this could be b, but c has to be the side across from the 90-degree angle. So a and b are the variables that represent the lengths of the legs of the triangle that form the 90-degree angle. And let's scroll down. And C, again, is the variable that represents the length of the longest side. And it is opposite the 90-degree angle. Okay? So, if the side lengths of the triangle satisfy the equation a squared plus b squared is equal to c squared, then the triangle is a right triangle and c is its hypotenuse. So example 1 says, is a triangle with the side lengths 3, 4, and 5 a right triangle, and how do you know? So we know that this would have to be c because it's the longest side, and you just see if it satisfies the equation 3 squared plus 4 squared equals to 5 squared. And you'll see this is 9 plus 16 is equal to 25. And so yes, that is a true statement, and that is what we call a Pythagorean triple, which is just simply a set of integers that satisfies the equation a squared plus b squared is equal to c squared. So, is a triangle with side lengths 1, 2, and 3 a right triangle? And how would you know? Well, again, you would just see, does it satisfy? Well, 3 is the longest number, so that is 1 squared plus 2 squared equal to 3 squared, equal to 3 squared. And we get 1 plus 4 is equal to 9. That is not true, so that is not a right triangle. So integers are a set of positive and negative whole numbers, and 0 has no fractions or decimals. And a Pythagorean triple is any group of 3 positive integers a, b, and c such that a squared plus b squared is equal to c squared. So example 2, is 7, 24, and 25 a triple? Well, let's see. Is 7 squared plus 24 squared equal to 25 squared? 7 squared is 49. 24 squared is 576. And 25 squared is 625. And if you add 49 and 576, you're going to get 625 is equal to 625. So yes, that is true. So 7, 24, and 25 is a Pythagorean triple because a squared plus b squared is equal to c squared. All right, and then what about 5, 12, and 13? Please pause the video for a moment and see if 5, 12, and 13 is a triple. Again, you would say, is 5 squared plus 12 squared equal to 13 squared. And you should get 25 plus 144 is equal to 169, and yes, 169 is equal to 169. Yes, it is a triple. And then any multiple of Pythagorean triple is also a triple. So once you have a set of Pythagorean triples, you can find the multiples of those. So let's see what we mean. So if we want to generate some new triangles using the 3, 4, 5, we just take, we'll take 2 and multiply by 2 by 3, 4, and 5, and we will get 6, 8, and 10. We can multiply 3, and we get 9, 12, and 15, and so on. You can multiply 10 and get 30, 40, and 50. Any multiple is a triple. Same thing with the quick check. If 5, 12, and 13 is a triple, any multiple. So 10, 24, and 26. Or if we multiply 3, we get 15, 36, and 39. So any multiples of triples are also a triple. Describe the benefit of recognizing a triple. Well, it just saves you a little bit of work. If you recognize that we have a right triangle, it just saves doing a little bit of the arithmetic. And that's really the only real benefit. It just saves a little time. Okay. So now we're going to move into something that is real important in geometry. And we're going to lead into something called special right triangles, but we're going to start here in example 4. And it says to record the exact, okay, that's very important. Let me get a different color here. The exact and approximate length to the nearest tenth. So here we have a square. And so if you have a square, and if you draw a diagonal in a square, it cuts this angle in two. And so these would be 45-degree angles. And so what you have here now is you have two triangles which have the dimensions, or the angles. I'm going to draw it right here. Of 45, 45, and 90 degrees. Okay, so they say the square has a side length of 1. So these are all 1. Okay, so if we want to know what y is 45, we have that. But we want to know what x is. And so again, let me just put it over here. I have 1 and a 1, and I want to know what this is. So I can say a squared plus b squared is equal to c squared, and a and b are both 1. So that is 1 squared plus 1 squared is equal to c squared or x squared. 1 squared is 1, so 1 plus 1 is equal to x squared. So I get 2 is equal to x squared, which means that x is equal to the square root of 2. So that is the exact answer right there. And I actually don't have my calculator with me, so if you put that in your calculator, you'll get an approximate answer. It's probably about 1.2 something, but anyway, let's just worry with the exact answers. So the square root of 2 is the length of this hypotenuse. Okay, let's look at the next one. All right, we have a square. It has a side length of 10. So 10, 10, 10, and 10. So y is again 45 degrees. So again, we have these triangles that are created that have measurements of 45, 45, and 90. Let me draw that over here for you. We have this triangle. The angle measurements are 45, 45, 90, and this side is 10, and this side is 10. And we want to know what is the length of the hypotenuse. So we're going to say 10 squared plus 10 squared is equal to c squared, or x squared. We get 100 plus 100 is equal to c squared. 200 is equal to c squared. We want to simplify that. I can rewrite 200 as 100 times 2. And what's the square root of 100? It's 10. So this simplifies to 10 times the square root of 2. So the exact answer here is 10 times the square root of 2. Okay, and what I want you to start looking for is a pattern. Let me look at the next example. Okay, perfect. Well, no, before we go to that next example, let me show you another picture here. So this is the pattern that you should start to see. I'm going to draw some triangles. These are all supposed to be 45, 45, 90 as far as the lengths. Okay, the first one we saw, we said that this was 1 and this was 1 and this was the square root of 2. Try a different color. How about this one? This was 10 and this was 10 and this was 10 times the square root of 2. So let's see, if I tell you this is 15 and this is 15, what do you think this will be? 15 times the square root of 2. So again, if you have a right triangle where the other two angles are 45, you're going to see this pattern. And if the side lengths are an integer, it needs to be an integer. Say the side length was 8 and this was 8. The side length here is going to be 8 to the square root of 2. All right, let's look at example 5. Slightly different, I think. We have a diagonal length of 8 to the square root of 2. So maybe you see the pattern already. Now if this is 8 to the square root of 2, what are these going to be? We'll call those x. You might already know, but let's solve it the algebra way. Well, we know that a squared plus b squared, and a and b are both the same because it's a square. So x squared plus x squared equals 8 to the square root of 2 squared. So that is 8 to the square root of 2 times 8 to the square root of 2, which is 8 times 8 is 64. The square root of 2 times the square root of 2 is 2. 64 times 2 is 128. So we get x squared plus x squared, or 2x squared, is equal to 128. If we divide both sides by 2, we get x squared is equal to 64. And the square root of 64 is 8. So if the diagonal is 8 times the square root of 2, the side lengths will be 8. All right. Now this one is going to be a little bit slightly different. Okay, we have a square that has a diagonal of 8. So this one, this is 8 and this is x and x. So let's see what this looks like. We get x squared plus x squared is equal to 8 squared. 2x squared is equal to 64. Divide both sides by 2. X squared is equal to 32. X is equal to the square root of 32, which can be rewritten as 16 times 2. So you're going to take out the 4, and this is going to be 4 to the square root of 2. So x is 4 to the square root of 2. Okay, I'm going to have to pause the video here because this is kind of long, and we'll work on, I'll make an additional one.